In this video, we're going to take the time to go ahead and start building our first model. This model is going to be a connection object that allows us to interact with our database. So we're going to separate all that logic out into some models here. To get that code, go ahead and get the resource file citymanagerwebdblistcities.war, and that file will be used in the next couple of videos. Once you import that, you're going to want to go ahead and rename your project to City Manager Web. Now this also brings up another point. Since we're going to be working against the database, we're going to want to make sure at this point that we have our database installed. So if you haven't yet installed your MySQL database, now would be a good time to do that so that you could start building your code and interacting with your own database. If you decide for some reason you don't want to use MySQL, that's fine. There are other options available to you. You may already have some of them set up and may want to use that. I've modeled this data in a way that you can easily create your own server connection behavior and interchange that code so that you don't have to rebuild the entire thing. You can simply make the methods available that you need in order to specifically connect to your database. And you'll see that as we build the code here in a moment. The other thing that I've done is created a specific user for my database. So rather than just using the root user, I've created a user called dbuser with the password 12dbuser that's going to be having permissions only on the world database. It's just a little more secure. You could, of course, use your root user if you wanted to. That's completely up to you. But I do have a separate user in place. So you'll see that being used here. And actually, these context parameters are set up so that I can easily interchange that, and you can interchange that information in the web XML file as well if you need to have different username, different password. Just make sure that you leave the parameter names the same because we'll be pulling from that in a moment. So we have an interface called server connection behavior. Let's go ahead and start expanding this. Our server connection behavior is just going to expose a few methods for any connection behavior. Get connection URL, get connection details, and get table schema. So the get connection is going to be our main one if we ever wanted to grab the connection out and work with it. Connection URL will be the actual connection parameters that we need to make a new connection. Connection details is just a string that's just going to tell us about what we're doing with it. And table schema query was just a way that I built in there in case you ever wanted to do a simple check to make sure that you actually are connected. You could easily see that you could get your tables. And it is interchangeable then by exposing it through the interface. Polymorphically, it won't matter who's implementing it. The other object we have here is a dbuser_info. It's just an abstract class that consists of a user ID, a password, and a catalog. That way we can easily have that information available to us for building our connection strings as we go, our connection URL. And we can use this, and we'll actually implement this by extension in our connection behaviors. So the next object that's important is the MySQL connection behavior. So once again, this is going to extend dbuser_info, giving us the catalog, user ID, and password, and it's going to implement the server connection behavior so that the DB manager can easily interchange this object and connect to MySQL correctly. We set up our DB user then with our user ID, password, and catalog, which we'll pull from init parameters, and then we'll be able to get the connection. And when we get the connection here, we're going to actually create the connection object. So that's going to use the class.for name, and here is a MySQL driver, com.mysql.jdbc.driver, creating a new instance of that. And then we'll create a new connection, which we'll use to essentially get the connection and return that as an object. So we'll use drivermanager.getConnection on the URL specifically, thereby setting our JDBC driver connectj to connect to our MySQL instance. If you were doing this in a more robust situation, you probably want to log this if there's a major error. Get connection URL is going to be an important parameter used again when we create our connection there, but also so that we can verify and see our connection information. So here's jdbc:/mysql:/localhost and then catalog. And then we have some parameters, user equals and password equals. And we'll just use our local get methods in order to set those values, again, created by either setting them or in the constructor for the catalog, user ID, and password. Getting the connection details, once again, is just a string, MySQL database connection to whatever our catalog is. And get table schema is, again, just another way that you could use as a quick check to basically say, these are my tables in my catalog, if you ever wanted to get them for whatever reason. So once we have our user information set up, we have our server connection behavior configured, it's time to take a look at our DB manager. So the DB manager is going to be our main model that's going to essentially be able to be used in our system. I've implemented serializable in this in the anticipation that this will go into session, and so we may actually need to modify MySQL behavior to also implement serializable here when we get to that point. We won't worry about that right now. The connection itself will be used locally here inside of the DB Manager, and we need a server connection behavior, of course, to interchange that behavior and be able to connect to any database using this DB Manager with a correctly set up server connection behavior. We can construct it with the connection behavior. We can set the connection behavior by passing one in. We're going to have some methods available to us to interact with our database. One is going to open the connection. Essentially here we're just going to make sure our connection is not currently open, and we'll get the new connection, and that will be our connection object on our DB Manager. Again, here you would want to do more robust logging than just printing a stack trace. We have close connection, which allows us to close the database connection. We have a keep alive Boolean, which allows the user to completely destroy the connection object by setting it to null. We have a check to determine if our connection is actually connected at this point, if connection is not equal to null. And we have an execute non-query, which you pass a query into, creates a statement, essentially executes that statement, and closes it. Returns true as long as the query successfully executes. And we have an execute result set, which is going to be used here in our next lesson when we actually see some data coming out of the database. This will actually allow us to get a result set back from the database using a prepared statement and a passed-in query. We can get the connection if we wanted to actually work with a connection outside of this object. We can get the connection URL if we need that. We can get the table schema query if we need that. So those things are just exposed through the DB Manager for us. So with all of that, we've actually now seen all of our model code in place. So what we'll do next time when we come back is we'll go ahead and start working with this manager and build a quick way that we can use a servlet to render the cities from our world database.